What is that shape in general called? Say it out loud if you know it. Parabola. Good. What if I said that that spot was important? Would you agree? What's its name? The vertex. If I said that that vertex was -4, 1, does that sort of make sense for where it is on the graph? -4, 1? Okay, good. Then what's the dotted line called that runs right through the middle of this whole thing? Axis of symmetry. Everybody write so far what I have done. Just copy this onto your iPad, and then I want to know what this guy's name is. If you know its name, I know it's the axis of symmetry. But I mean, is it like y = 7? No. Write its name in this little circle down here. And I'll pause for a second while you give that a try. There's a name for the dotted line. I know it's the axis of symmetry, but it's got an actual like address, and it's not y = 7. What is it? You are correct. X equals -4. So it's the X is always the most important of the numbers. Also because that's the number you use when you're talking about increasing and decreasing. This part here that I'm shading in, during that part, is it increasing or decreasing? Increasing. Please write the name for it. What, what? That zone where it was increasing. Hint, it has to do with the vertex. Remember me saying yesterday that the principal was kind of like the most important person at high school? Because he can suspend any one of you. He can kick me out. He can fire me. He can decide that we're not having school tomorrow. I mean, he's got a lot of power. He can do a lot of things. Well, this vertex is the big thing. So it's involved in almost everything. So when I said to write the interval where it's increasing, raise your hand if you knew that it was -4 to infinity. Okay, that's like half of you. So let me show you that again. This is how you say it. You say it starts right here and it goes that way. And as long as you go that way, it keeps increasing. So how do you say that big giant blue arrow? -4 is where it started. To infinity is kind of like where it would end. Doesn't end. Okay, so then when's it decreasing? Well, this part is where it's decreasing. How do you say that? It's always something, something. Everybody write that one down. I'm going to pull up a random person and ask them, when is this thing decreasing? The decreasing part of the parabola. The interval over which the parabola is decreasing. Do you have the answer? Say it. Infinity, -4. Why did I say -infinity? Because it's way over there. And way to the left is where -infinity is. Why did I stop at -4? A lot of people don't get that. They think it should be 1. And I get it. The height of it is 1 right there. But that's not what we care about. We don't care about its height. We care about how far over you go. And X things, like this -4, are how far over you go. All right, I'm going to give you another one that's like that. I'm trying to prevent mass bloodshed on my next test because this question always gets people. They're like, I don't get the increasing and decreasing thing. So if this is 3, -2, what is the decreasing interval? DEC, the decreasing interval. This time I want you to compare what you think the answer is to the kid next to you. What do you think the decreasing interval is? Okay, we're back, and you should have said that it decreased kind of in this zone. You know, it's going down. Then right there, it stops. So then it's -infinity until it stops at 3. Raise your hand if you had that one right. Sweet. And then the easier one is the increasing interval. I'm calling on random kid. Row 2. Last person. All right. You got this. Taylor. The increasing interval Yeah, you're the second row. 3 comma infinity, you're using the y value. No, wait, no, I'm wrong. That was from here. Okay, this point is the 3, so you're right. 3 comma infinity, good job. Okay, raise your hand if you had that one right. Okay, good. That's gonna be the one people get the most. Okay, how about this spot and this spot? Are they important? Yeah, they're called x whats? Intercepts. How about this spot here? Y-intercept. Okay, good. Now, let me teach you some new stuff. If this right here was at 4 comma 0, that means the equation would go like this, x minus 4. What if this spot is at 1 comma 0? Then I'd have x minus 1. And boom, I've got the equation. X minus 1 in parentheses, x minus 4 in parentheses. You ever seen anything like that before? All right, everybody write this one down. X squared plus 3x minus 4. That's called general form of an equation. Put a little y equals in front of it. Everybody put that y equals in there. Now, imagine I had a bunch of tools in front of me. You know, you got a hammer. What's a hammer good for? Well, pounding in nails, for example. Okay. What if I have a drill? Is a drill good for that? No, it's got its own special job. Drill is for drilling holes. You make holes in things. What's this for then? One of the best things it's for is telling me the y-intercept. You get how it's just sitting right there? It's super easy to see. It's just right there. That's the y-intercept, and that's why this is handy. Otherwise, I'd rather have this. Let's see if you can hang with this. This is the factored form of this, and I go like this. X and x, because then it makes x squared. And 4 times 1 makes 4, and one of them needs to be negative, and then one needs to be positive, and then if I multiplied this out, I'd have x squared plus 4x minus 1x minus 4, which, whoa, is the same thing as I had in the first place. What just happened? I factored that. What's factored form good for? It's a tool. You know, the other one was good for the y-intercept. This one is good for the x-intercepts. 1 is one of the x-intercepts because it makes it equal 0. Negative 4 is the other x-intercept because it makes it equal 0. Watch how easy that is then. Here's 1, positive 1, and here's negative 4, and I know it's a parabola, so look, I can graph it so quick. Okay, what just happened again? I factored it, and the two factors told me, one of them told me this one, and the other one, I'll do it in red, this one here, told me that answer. Okay, let's see if you can handle that. Everybody write this one down. X squared minus 4x plus 3. What's that good for? The y-intercept. I know it. Do you know it? What's a y-intercept? 3. So if I had to graph this thing, I would know right away that the y-intercept was 3, and it's right there, and that's all there is to it. You just have to go like that. Yay, I know my y-intercept. Okay, so what's the other thing I can do? Well, I can factor it. I don't know how many of you can do this, but it's on the basic 20. Do you remember how to factor this? I'm going to pause for a second. Everybody try to figure out what goes in here and what goes in here. I'm pausing. So I have my first proposal, and the kid said plus 1 and minus 3. You're close, because 1 times 3 does make 3. But what's wrong with your answer? It makes negative 3. And I want it to be positive 3. And I know you were thinking, but I need a negative in it because there's a negative right here. So you weren't wrong that you needed a negative. You just needed 2 negatives. Do you get what I mean by that? If I do negative 1 times negative 3, it'll make positive 3. And that was the answer. X minus 1, X minus 3. Yes, ma'am?
Why can't you do 2 positives?
Okay, if I do 2 positives and I make it positive and positive, it will make a positive 3, but it won't make this part be negative 4. See, when I multiply this out, would I ever end up with getting a negative on anything? No, I need negatives, so it's only possible if I use 2 negatives. It's like 2 wrongs will make it right. 2 negatives. Makes it positive 3. And then when I multiply it all the way out, this times this, x squared. This times this, negative 3x. This times this, negative 1x. And this times this, positive 3. All right, so many important things that we are going over right now. This and this are 2 forms of a quadratic. One's factored and gives me the x-intercepts, the spots on the x-axis where it touches. And this one gives me the y-intercept. Sage.
So when we're factoring it, are we trying to do the make the negative 4 or the 3?
When you're multiplying, you're trying to make the 3. All right, so let's try that one more time, but this time I just want to make sure you can multiply this out, because if you can't multiply this out, then I can't teach you the other stuff yet. Everybody multiply this out. If you've forgotten how to do this, hint, you just distribute the 3 to both of them, and then you distribute the x to both of them. If you can't do this, I gotta know now. So everybody multiply that out and write what you think it is. And I will walk around and you show it to me and I'll tell you yup or nope. I was feeling like there was a bunch of people that didn't know how to do this, but it looks like you do. X squared is for the first part, then plus 2x, then plus 3x, and then plus 6. That's x squared plus 5x plus 6. What's this one good for? X-intercepts. What are the x-intercepts? Not 3 and 2. Remember? Opposite of what you would think. Negative 3 and negative 2. So if I was going to graph this, here's where negative 3 is. And here's where negative 2 is. And then my parabola has to go through them, and it goes like that. Does that make sense to you? How come they're negative? Well, because they're the opposite of what you would think they are. You know, because we don't trust the inside. The other way to say it is, if I stick a negative 3 in the equation, it makes this part 0 and starts a chain reaction, because 0 times anything is just going to keep turning into 0. If I put a negative 2 in here, then I get 0, and the whole thing has to equal 0. So those are called zeros. X-intercepts, roots, and the solutions. So those are obviously a big deal. Okay, question.
So the one that we just did.
Yep.
So that means it was x minus 1 and then x minus 3, so it would be.
Okay, wait. You're changing problems on me? I'll go back to this one.
Yeah, the one that we just
Okay,
did.
yep, this one.
But would it be then
Positive 1 and positive 3. Yep, positive 1 and positive 3. And look, if I was going to go through the y-intercept and then go through these two, see how that works? So yeah, you use the opposite of whatever's inside the parentheses. So, there. Now, why did we multiply that all out? Why can't we just leave it as factored? Because this tells me the y-intercept. And it also tells me A, B, and C. Y'all want to know your ABCs, right? Well, in math, that's this number, that's the A, this number's the B, and this number's the C. A, B, C. When would you ever see those? X equals negative B, plus or minus square root of b squared minus 4ac. Notice a's, b's, and c's. All over 2a. You're really close. Okay. So one more time, let me give you an equation, and I want you to try to factor it. X squared plus 7x minus 8. Right now, I know the what? The y-intercept, and it's negative 8. So if I was going to graph this thing, I would already know down there, it goes through right there. Goes through that spot. That's where it touches. But I know a lot more if you can factor it. Can you? I hope you can. This is called Algebra 2. And what you're doing right there, that's regular algebra. Okay, so quick reminder how this works. These two numbers that go here and here, they gotta multiply to negative 8. Now there is two choices. Do you agree that 4 times 2 makes 8? But that wouldn't work. Why? Because if I put in a 4 and a 2 and make one of them negative, I can't make a 7 happen here. So the 4 and the 2 are out. Why? Because if you multiply it out, you won't get 7x. So if it can't be 4 and 2, the only other choice, 8 and 1. 8 times 1. And does one of them need to be negative, or do both of them need to be negative? One of them needs to be negative to make it negative 8. So this will be negative one of these two, and I don't even know which one. So let's say I just guess one, and I think that one's negative. I have a 50-50 chance, okay? So I try it. And here's what you do. You go x times x, and it makes x squared, and it all looks good so far. And then you do x times the 1, and that makes plus 1x, and that looks fine so far. And then you go this times this, and you get negative 8x. And then you start getting nervous because, wait a minute, what do those two together make? Negative 7x. And I wanted positive 7x. So crap, it didn't work. So what do? I got the exact opposite of what I wanted, so I changed to the opposite signs. That's positive, and that thing that was positive becomes negative. And boom, I know I've got it now. I'm good enough at this that I don't even have to check it. Well, that's kind of dangerous. Like, because you're probably not that good at it. You're not a math teacher. So you check it, and you go x squared, outside negative 1x, inside positive 8x, last negative 8. And did it actually work? Yeah, it did. Cool. Well, that's what you had in the first place. You just wasted all your time. No, I was checking it to make sure it's working. Okay? And now, why did we even factor that? Because negative 8 is a what? X-intercept. Positive 1 is a what? X-intercept. There's two X-intercepts. This and that are the X-intercepts. Negative 8 and positive 1. And that's what my parabola generally looks like. Asymptote runs down here. I know it's a little bit bent, but you know, that's the idea. Okay, let's give you one more try on that. Y equals x squared plus 2x minus 3. Would everybody please factor it and then make a sketch of what it will look like, because you'll know the x-intercepts and you already know the y-intercept. Pausing for a second while you give that one a shot. He's proving he's right. X times x, x squared. Keep going.
And then x times negative 1 is negative 1x.
Keep going.
And then 3 times x is 3x.
And then?
And then 3 times negative 1 is negative 3.
Nice. Put it all together. X squared plus 2x minus 3. And that's what I had in the first place. And all that means is that, yay, this was right. We checked it. It's right for sure. Now, everybody put dots where the x-intercepts are and where the y-intercept is. And then play connect the dots. I'll pause for a second while you try that. So, you should have said the y-intercept was -3. The x-intercepts were +1. Why +1? Because you don't trust the inside. -3, which is like over here. And then can you play connect the dots? I can. Goes down like this. Goes up like that.
Your Tesla's on the screen.
Oh, sorry. Thank you. HDMI. And there you go. It should have looked like that. Raise your hand if yours kind of looked like that. Good. If you wanted to try to keep yourself organized, you might put this little dotted line down the middle. You know what it's called? The what of what? Axis of symmetry. Very good. And it would run right through the middle of the vertex. We never figured out the vertex, but I can tell you it would have probably been -1, -2. And if so, the x of the vertex would have been x equals -1 for an axis of symmetry. I think that's what it was. Sage.
If I did -1 and +3, is that fine?
No. If you said -1, you didn't reverse this to be the opposite. You know, you want the opposite of what you see. So you did not want -1. You wanted +1. Let me show you why. I get you why you say that. But if I had these two, does -7, when I put it in here, actually make this equation equal 0? No. Do you get I have to change it then? So I could not say it was -7 and +5. The right answers would be +7 and -5. You'll always have to do the opposite of whatever's in the parenthesis. Because get how that would equal 0? But if I would have put in +5, it wouldn't have worked. Do you get how this would equal 0? But if I would have used -7, it wouldn't have worked.
Wait, so when I graph it, I have to, so if I had, okay,
So when you graph it, these are the points you put on the graph.
Yeah.
You'd graph -5, and you'd graph 7 on this one. Okay? So always do the opposite of the number that you see inside it.
Okay. But, so then if I were to write x plus 1 and x minus 3, then would I have done?
Yes, x plus 1, +1, would have been a right answer. That's this guy right here, +1. And -3 would have been the right answer here.
And then I would have put it.
And those would have been these two spots, +1 here and -3 there. All right, let's move on. So go to this page right here, and I want to show you an example of each one. Everybody write this right above it. Y equals 2x squared plus 3x plus 1. So what's that good for? It tells me A, B, and C. And the y-intercept. Thank you very much for remembering that. This one gives you the y-intercept. Okay, what if I factored it? I know that's a tricky one, but I will factor it for you. And it goes 2x plus 1 and x plus 1. Why is this not really better, but different? Because it gives me not the y-intercept, it gives me the what? The x-intercepts. That's this form. That's called factored form. But there's no number in the front, Mr. Server. Yes, there is. There's a 1. There's always a 1 in front if there's nothing else. Okay? Do you get how this one's factored and the two things you have are the x-intercepts? There's always two x-intercepts. Well, not always. Sometimes it's the same one twice, like x plus 1 and x plus 1. It's kind of more rare, but it comes every now and then. And then there's this form, last one, y equals 3, parentheses, x minus 2 squared plus 7. I know your brain is full. It's near the end of the day, but stay with me. This is the most important form. This is the boss. Know why? It's got the vertex in it, which I told you is like the principle of the high school. It's the biggest deal about the whole parabola. And the vertex isn't 2 comma 7, but it's really close to that. Who has a theory? Come on, you could do it. Use logic. Alexis. Negative 2 comma 7. What was the logic there? No, wait a minute. Dang it. I said it wrong. It was 2 comma 7. That's why I had people looking at me funny. It is 2 comma 7. But why did I think it was supposed to be negative 2 comma 7? Mondale?
It's negative in the formula, so for it to be negative in the actual vertex, it has to be positive.
Yup. Basically, it's that whole opposite of what you think thing. I was thinking for sure the answer would be negative 2 comma 7, but it's not. It's 2 comma 7. Do you get what I mean? It's always the opposite of what you would think in there. That's the vertex. All right, now last one. Let's see if you're in the top half of the class. Because I think only the top half of the class can answer this hardest question. We're going to review this like every day until you guys get it. If that's 4 comma 1, what is the decreasing interval? Would you agree this thing is decreasing at some part of its life? It's decreasing?
Yeah.
So, what's the decreasing interval? Don't say it out loud. Give people a chance to answer. The decreasing interval. Now, I'm not going to make you say your answer out loud because I know a lot of you said the wrong thing. I think a lot of you knew that it was 4 in the answer, and you're right. Raise your hand if you knew there was a 4 there. But I think a lot of people were going to say negative infinity because they're like, it's going down really low, so it's negative infinity. Nope, it's positive infinity. Why? Because from here over there, it keeps going that way forever. That's the infinity we're talking about, which is over here. Yes, down here is negative infinity, but the x numbers, this is the x values, are from 4 to the other x value is infinity. It's really common for kids to say 4 negative infinity. I won't make you tell me. All right, so it was 4 to infinity. That was the decreasing interval. Okay, now you have a Scrooge, kids. It's there waiting for you. At a minimum, you can open it and start it, and I'm hoping you can get 2 or 3 problems done. Everybody, please start right now. If you're started, my dad always said you were halfway done.